Hi, hello everyone. Well, Emil, welcome back to my YouTube master. In this playlist, we are going to talk about the Delta Live Table end-to-end project. We have made the first three live table. First one was on the introduction to the live table. Second one was a part one at the Delta Live Table UI, creating a pipeline and running it. And in the part two, we have seen code how we can create a Delta Live Table pipeline, the sets of the Delta Live Table, streaming table, and materialized view. Now we are going to take our own use case, e-commerce use case, and we are going to build a complete end-to-end caption project. You will not find this video anywhere in the YouTube because a real-time real data set I've just manipulated and I've taken a sample data, and we are going to implement it complete end-to-end, starting with a raw data, finally goal layers and creating a dashboards, all in the Delta Live table. So let us begin now. Let me explain you a sample data set what I am working on. So first I have a sales data. You can see I have these many columns, and in this columns, if you look detail, we have a record still. Few are duplicate records, few have a null values here, and few have a null values here also. Okay, few nulls, few duplicates, the sales table. Then we have a product table. You can see it's all CSVs, not table actually, it's a CSV files. We have a product CSV, we have these columns, and we are going to implement SCD type 1 on the products and SCD type 2 on customers. I assume that you are aware of what is SCD type 1, that is slowly changing dimension type 1, where type 1 means it's just an overwrite. Okay, we are not maintaining the history here. So here you can see the first one, we got a record, it's insert. So these 5 got inserted, and the next time the first record was deleted. So the operation is delete here. So to implement SCD type 1 and type 2, we need this operation column, and it's mandatory. Without that operation column, we cannot implement type 1 and type 2. So we got this data from the source itself, which records got added, which records got updated, which records got deleted, and at what sequence. So we need to know the sequence also, like how the data is coming in. So we are getting these files on a regular basis, on a daily basis. That is what our assumption is. And we have a customers data. So you can see the customers data. We have customers record, and few customers address got updated. Can you see that ID2 got updated here, and few got deleted. Maybe third one got deleted, and the sixth Robert got inserted. So few inserts, updates, and deletes, and we are getting these files on a regular basis. We have a customers one, we have products one, and the sales team. Now what I have done in my data lake, I have created one directory called DLT, and in that I have just created 3 directories again. So I'll be uploading the files here manually. So this is a customers CSV file, this is a product CSV file, and this is a sales CSV file. We can take a traditional approach to solve this, like go to the notebook, use a data frame style or a PySpark SQL style and implement it. But we have choose the Delta Live table because when it comes to implementing CDC data, handling or implementing SCD type 1, type 2, and monitoring, improving the data quality, Medallion architecture, everything becomes so easy with this one single framework, and it's called Delta Live table. How to implement it, we are going to see it with our own use case. Okay, so let me go back to the DLT notebook. So I have created a DLT notebook. First we'll try to start writing the code. So previously we have looked at in the reverse way. First we looked at the UI, and then we started writing the code. But now we are going to do 2 things. First we'll write a syntax, we'll write a code, and then we'll go and try to run that in a pipeline. So to run the pipeline, again it's a job compute. This will take some couple of times to start it. So we are going to write one simple code, we are, run them in a pipeline, and then we'll attach that pipeline to the notebook, and we'll try to test it and iterate it. Yes, we are going to attach that pipeline to the notebook. Sound weird, but let me show you. So I have shown you the sample data set. I have shown you the sample script. I'll copy it from there just to save some time. Okay, that go here, pipeline, this, copy the first one just to save. Now I'll do a couple of changes here. I'll remove the comment and table properties. I'll play with that later on. First, I'll focus on the code. Select star from the cloud files, and this time it's not the Databricks sets. This time it's going to be my mount point. So it's MNT. I remember the mount point. So I explained you how to do the mounting. Or if you do not have the mounting, you can put all your data in the volumes and you can pull that volumes out. Let me get inside this. I have a container storage account name. Take a storage account. The container name is raw, and in the raw we have a directory called DLT, I guess. Yeah, DLT. In that we have just write DLT, and then we have a folder called yeah, it's sales. And here I'm say create streaming live table as a sales. I'm not going to do much change. Very simple. This will help me to create a data ingestion, like ingest the data into the bronze. Now the beginners might get confused again. Okay, you are creating a table. Where is a schema? Where is a catalog? Did you mention anything? No, we are not going to mention anything in the code, but we are going to mention them in the catalog. We are going to mention them in the pipeline. When we are creating a pipeline, we'll configure it. We'll mention a catalog. We'll mention the schema. We are going to mention the compute size also. Now let us jump on to proceed to the DLT pipeline. From here, let me go back to the workflow DLT. We already created one sample. Now we are going to create a new pipeline. This time I'll just click on create pipeline and not a sample pipeline. Click on create pipeline. You get all the details about the configurations. I have already explained it. Now I'm not going in detail. Let me quickly start giving a name. So this is a ecom project actually. I'll say ecom DLT. I'm going to choose an advanced because I want to implement CDC data, SCD type 1, type 2 and all. Let me keep a pipeline mode as triggered. I'm not going for the streaming data, a real-time data. So I'll trigger. Now you need to choose your path. Where is your notebook of that DLT? Let me choose it from here. I'll source folder. Okay. So this is your DLT. Actually, I'm taking up the same notebook and I'm attaching to the node, the pipeline. Now you get an option to choose it from the Hive meta store and the Unity catalog. We will be moving to the Unity catalog only. We will switch to the Unity catalog, and here I'll be choosing a catalog that data master consulting catalog, and then I'll choose a target schema. So this time I'll choose it like a com project. Okay, I'll just keep it as a ecom project, and if this schema is not available, it will try to create a new schema, new database, and all the tables what we are working on this, that will be just attached to this schema. Now you need to remember few things here. Whenever you are using a Unity catalog, you need a compute that has at least one worker. So your Unity catalog doesn't allow you to use a single node. That is basic again. So if you are switching to the Unity catalog, you need to use either a multi-node with one driver and one worker. So that's the reason why I kept one worker. You remember in the previous sample data set, we used the Hive meta store. There I used the compute and I kept the worker size as 0. It should work. Definitely it should work. But in this case, it will not work because I want to push it to the Unity catalog. Now making the worker node 1, you can look at the DBUs. You can keep a eye on this. You can increase the worker node, if you can decrease the worker node, and so on. But our use case is very simple. We have only few records, just focusing on building an ETL. But in real time, depending upon your data size, data volume, you can choose the number of worker nodes. Notifications, we have kept it advanced. We are not going for the key value. Now, as I told you, in my core and in my quotas, Azure quotas, I have a very specific a node type that is available. So I'll just take that. I'll go to the worker type and I'll choose DC4AS. If I am not choosing it, so DLT will just by default pick up the node type, like any random node type. So again, I might get an error that these cores are not available. So that's the reason why I'll be very specific. And when you are working on the enterprise level, you don't need to do all this. Your DLT will take care of pulling out the computes that are available, and your Azure admin will take care of making the cores available for you. You don't need to worry anything. So I'll just choose it from my end. It's not mandatory. I can see here it's not mandatory. Now, without wasting much time, let me just hit on create. So I have configured everything for the pipeline. Once the DLT pipeline is created, there will be one job compute. I can use that job compute and start iterating it. So yes, I have just created only small syntax, but I'm going to iterate this. So when I come to iteration, when I start developing it, we need a mode called development mode. Let us stick to the development mode, and I have explained you all the other details. Now let me hit on start. So this is going to take a long 4 to 5 minutes now. I'm going to pause it here. I mean, once I start it, I'm going to wait for a long 4 or 5 minutes. Once the compute starts, we are going to proceed further. I'll just go to the compute now. I'll go to the compute section and I'll show you that there would be a new job compute that is running now. It will not reuse the previous computes. It will just start a new compute now. So it will take a long 4 minutes to spin this. And once it's spin, it will attach, and then you should see only one table in. Okay, wow, you can see here we have run a pipeline, and I can see a streaming table that is created, and it's a sales table. I can see so many stats here. It took only 12 seconds to execute, and it's only we have 78 records in it. You can go to the details here. You can see it's completed. Pipeline is completed, all the details, but you click on the table, you get the details about the table, the data quality, all the 100% records have been written to the ingestion layer. You can see the schema. These are all the data columns with the data types. You can check the flow, whether it's an incremental and so on. You get all the logs here. So it took 5 to 6 minutes to run, and then we can see the graph. Now let me go back to the DLT notebook and let me show you this notebook. This is so amazing here. When you come to the notebook, it is showing you that, hey, this notebook is associated with the DLT. So you can just go to the connect, and here there is one DLT pipeline job. So this is again like beginners get confused here. As I told you that you cannot use the job compute in the all purpose, job compute in the notebooks. But yes, here you can do it. I mean, it's a Delta Live table pipeline. It's a Delta Live table pipeline. So we are not using a job compute actually. We are just taking that Delta Live table pipeline. That is my Delta Live table pipeline is ecom DLT. I have just attached that to my notebook. Oh, once you attach it, you can see the UI is changed. It's so amazing here. You get the Delta Live table graph in the notebook itself. You can see that in the notebook itself, and you get a Delta Live table event logs here. You get a query history. Everything can be seen here. So you don't need to go back to the Delta Live table pipeline to check the details every time. You can do all the changes. You can do the iterations in the notebook itself. Now what I'll do, I'll just copy this just to save some time and copy and paste it. If you remember, I've shown you 3 data sets. Sales, customers, and the products. Let me take a customers table now, customers, and then I'll just write it like a customers here, and let me try to run this. And you cannot run this here. So you cannot run this cell from here. You have to run it using a pipeline only. So we just click on start, and your entire pipeline starts now. And remember, we use the development mode, so your job compute is running, so it doesn't take much time now. The iterations becomes very easy. And if you ask me, like, in this notebook, can I write a normal SQL query? No, you cannot do it because the compute is different. You cannot go and attach the SQL warehouse here and write a SQL query. For example, if I write select star from the table, it throws you an error saying that, oh, this is a pipeline. a notebook is attached to the pipeline, you cannot run the normal SQL codes. You need to remember that. So let me just cancel this cell. I'll keep it only the commands that are dedicated to the Delta Live tables and nothing else. And here you cannot run this. I'm repeating it again. Just you can validate it and you can start it. So every time you have to start a pipeline. So now when I start it again, you might think like the sales table is already created. Can we see that? Yes. Let me go to the catalog, and in the data master catalog, we have a ecom project. Can you see that? In this, a sales table is created. But when I start a pipeline again, will you get an error that table already created? No, my dear, you don't get an error here because it's a cloud files. It's an autoloader. It's a concept of structure streaming. Once the files are read, it will not read again. So it will just pick up the new files that are coming in. The old files are not read. Okay, try to remember that. So let me click on start, and this time it doesn't take much time. You can see here it will just directly jump onto the initializing because the compute is already up and running. It will set up a tables, and both are independent. We haven't given any keyword like a live schema, so both are independent. And you can see customers table is created and the sales table is also created. And if you look at the detailing, so sales table was not refreshed. Can you see that? Sales table is already created and it's not refreshed because there is no new data coming in. Only if you get a new data, then only it will be refreshed. Otherwise it's not refreshed. Concept of structure streaming and autoloader, we have discussed that. Then we have a customers table and there are only 8 records in it. Now, can I check the data? Can I query it? You can do it, but in different notebooks, not in the same notebook. So in different notebook, you can attach your warehouse, you can attach your all-purpose compute, and you can test that. So now what I'll do, without wasting much time, I'll copy the same thing. I'll paste it here. Now I'll take a products table. Okay, I'll take a products table. Here, let me write a products table and just try to run this again. Now when you are running it, it's an ingestion. So do you recommend taking a current timestamp as a column? Can I add a current timestamp here? Can I do some enrichment here? Yes, you can do all. So you can just put a comma and say current timestamp and so on. Even you can go back to the sales table and the customers table, and you can even add those functions as well. So maybe let me add it, because adding a current timestamp is always a good practice. So I'll just say select star and then I'll say current timestamp here. Let me show you current timestamp, and I'll just call this as a ingestion date. Can I do the same thing for the other two? Let us try to do that. Okay, let me copy this, paste it here. We copy this, paste it here. Let me try to run this. Let us see what happens. And now you might be thinking like, oh, the schema might be mismatched because initially we had a different table, now we have a different, oh, we got an error. Let me try to check. So how to resolve this? Just go to the event logs and you can see you got an update here. Let me check what error we got it. So, oh, there was a syntax error. Actually, there is no space. Let me cancel this. Here, there is no space. Let me just put a space. It should work. Wow. Try to run this. This is how we try to iterate. This is how we try to test this. Okay, now it's initializing. So you don't need to worry about merging the schema. You don't need to worry about setting up a new tables. You don't need to worry about schema mismatch and all those things. Cool. Now let us try to check whether whatever the tables we created was correct or not. And you can see product table is there. We got 7 records. Let me go back to a notebook here. Let me create a new notebook. I'll just click on create, and this time I'm going to connect this to my SQL warehouse because the startup time is really fast. I'll go to the compute. I'll go to the catalog, ecom project. Let me refresh this. Oh, cool. I can see sales, products, and the customer. Let me take one of the table here and let me do quick select star from the table. Let me query this. You can see I have just queried a sales table, and your surprise, you can see you got got an ingestion date, but it's null. Okay, let me fix that. I'm not sure why we got null. Let me fix that. But you got a orders table. You can see orders table. We have some nulls here. We have some nulls here. We have some duplicates. We'll try to fix those. Now I'm going to take a different table. Let's take a customers table from here. Try to run this and check what is happening here. Okay, you have a customers data. Still in the ingestion date, we have a null records. We will try to fix that. And then we will try to use a products table. Let me try to run this. We got the products details, and at this time you got an ingestion date. So try to understand, previously we have ran it, but we did not create a new column. We have created a new column later on. So the table schema got changed, but there are no records. You don't need to worry it. So once we do a full refresh for the table, it will work. Definitely it will work. Now let me go back to the DLT notebook. So we got the results as expected. You can see we got a sales table, customers table, products table, and you can figure out from here. So why we got a null values in the ingestion? The reason is because this table did not read. Can you see that? It did not read. So to overcome this issue, we have a feature in the delta live table. You can go back to the delta live table and you can figure out whatever you have run it in the notebook. You can figure out all here. Like we have recent updates at every run. Every time when you start a pipeline, there is a update ID getting created. Can you see that? So at this time it was failed. You can check the details, why it got failed, which syntax, and so on. Let me get inside this, and cool. So this is the same UI what we are seeing it in the notebook. Now we have an option called select the tables for refresh. You can select particular tables. For example, we can select customers and the sales table to get refreshed. Or you would say that no, I want to do it a full refresh from the scratch. What does the full refresh means? It will truncate all the records from those tables and it will try to load it from the scratch. Yes, we have that option. You can just go to the start and you can see full refresh all. So let me just hit on this and let me click on confirm. Before confirm, you can see it's asking you that it will truncate and recompute all the tables from the scratch. If you are loading tons of your data, like if you have already processed GBs of the data, TBs of the data, so doing a full refresh is not a good practice. Now we are developing it, we are learning it. Our data set is very small, so we are doing it, but it's not recommended to do a full refresh if you have already processed a huge amount of data. Let me just click on full refresh. Now it will start collecting, truncating all those previous records, and it will reset the tables again. Now you don't need to worry about checkpointing, schema location. In autoloader and in traditional approach, we take care of all this. No, you don't need to do this. Amazing. Everything is taken care by the Databricks Delta Live table, and now you should see there are all records that got appended. Let me go back to the previous notebook. I'll try to query this and check whether the ingestion record is correct or not. Let me take this as a sales table. Try to query this. I should see the ingestion date. Wow, I can see the ingestion date now. It's really an amazing thing. Okay, so now we have done it. I'll come back to my notebook again, and here I'll attach this to my DLT. Oh, correct, it is attached already. Now let me start moving forward. We have ingested all the data, but all this data is just a bronze. It's an ingested. So if you take an example of sales, there are some duplicates, there are some null values in it. Let me try to fix this. Let me try to remove all that. In traditional approach, we implement our own logic, data frame, use functions like drop duplicates, we use a distinct in SQL, and so on. But in the Delta Live tables, we are going to drop it by distinct, as well as we'll move forward to implement a constraint also. So we have learned the constraint, we are going to implement it. So I'm going to take the code just below the sales, and I'm going to write create streaming streaming table. As I told you, live is just an optional. Now if you want, you can write it, or you can just skip it, because we are in the Delta Live table pipeline. It knows I'm going to say sales silver, and I'm going to say as, and then I'm going to write select star from, remember select star from. This time I'm going to use a sales table, and sales is in the same pipeline. It should be live dot sales. But remember, it's a sales silver is a streaming table. You need to enclose this to a function called stream. Okay. Oh my god. Yeah, this stream should come here. Stream. We are not going to take all the columns. We are just not copying it, but we need to use a distinct here. We're going to use a distinct. Cool. This should look good. So I'm going to drop all the duplicates by using this distinct, and let us try to run this. If you are going to, oh, you cannot run it from here. It's a Delta Live table pipeline. Let me start it from here. And you should create a new table. That table would be a sales silver, and it will be depending on the bronze sales table. So you will get a dependency, automatic dependencies. It's an amazing thing. Oh, cool. Can you see that? So this time only the sales silver table will be refreshed. I mean, only the sales silver table will be set up. Others table don't touch. You won't get anything here. You can see it took only 1-2 seconds to execute. Now we are running, or we are setting up a sales silver table. Now once the sales silver table is done, we can start querying it. We can test it whether as per expected or not. So let me go to the catalog, and here I'm going to jump on to sales silver, refresh this. Cool. You can see sales silver. Let me just write it like a sales silver. There were 78 records. Now let us see how many records we got here by doing this. We got 51 records. Let us test it here. Cool. Can you see that 51 records? And if you look carefully, let me do a sorting. Oh, cool. We got one null value. So after dropping all the duplicates, there is one null value that it has all the nulls. That record has all the nulls. Now, how do we eliminate this? In simple SQL, we will say that where your order ID is not null, but I'm expecting that order ID should not be null. I'm adding a constraint now. So how do I add a constraint? Let me show you. I'll just put a bracket here, and I'll say constraint, and you can see here Databricks. I mean, this workspace is so beautiful. It shows you all the intelligence. You don't need to remember the syntax and so on. So I'm adding a constraint. I'm writing a constraint name as order, valid order ID. Let me take it in this way. Valid order ID. Come on, order ID. And I'm expecting. Oh, I'm not getting a correct intelligence. No. Okay. Expecting my order ID is not null. Is not null. Okay, is not null. Just in case if it's null, I mean on violation, okay, constraint name, expecting the order ID is not null, on violation, you drop a row. I just want to drop that null values. I don't want to fail it. I want to just drop it. Now I guess the syntax is correct, but still it's showing you a red mark here. I don't know. Let me try to run this and see what happens. We'll validate. If it's showing you error, it should show you in the event log. It is showing me some error on the expect. Yes, my pronunciation also and my syntax is also wrong. Let me check. Let me do one thing. Let me go back to the sample data. If you remember, I'll go to the sample data. So my bad. I'm so sorry. It's not accept, it's expect. Okay. So let me take this on violation. Right? Or just a moment. Oh, cool. I missed the spelling. My bad again. So this should look good now. Constraint name, expect the order ID is not null, on violation, drop a row. Let me try to run this, and I should, drop that null value, null row. I should get a record without any nulls. So let me check now. I guess this should not work now because it's already red. It's already created. So we need to do only one thing here. Go back and do a full refresh. Then only you will get it. Otherwise you cannot. So let me go back and do a full refresh on this pipeline now. So I'm using two UIs. Don't get confused. I'm using a Delta Live Table UI also. I'm working on the notebooks also. Now let me go back to the notebook. Let me try to test it. So it was 51. Once the notebook got set up, I should see 50 records here. Oh, cool. This is what we are expecting. There is no error. Till now, there is no error. You should see only 50 records here. And click on this. I can go to the data quality, and you can see there is a constraint that we have set up, that expectations. Oh, cool. Can you see that one record got dropped and all 50 records got written? So the written percentage is 98% and the drop is 2%. Now I don't need to test it. So this is how the silver table is created, and it's a stream table. Now we have a customers table and the products table, and let me tell you, we are going to implement SCD type 1 and type 2 on these two tables. Like no one will do at this level. They'll just keep it very simple to the DLT, but we are going beyond that and implementing SCD type 1 and type 2. Cool. So we have created a bronze tables here, and on top of that we created one silver table from the sales. Now we are going to create a product silver and the product customer. But if you look at this, so if you look at the customers table and the product table, let me do that. Just show you the bronze tables now. Customers, take a SQL warehouse here. Start this. Okay, first we'll look at the product table. Let me click on start. It in a Let us try to analyze this bronze table. We do not have any nulls and duplicates, but still if you have nulls and duplicates, we can do the same thing like what we have done for the sales. You can do that. Okay, but in this we do not have nulls, but we have an data that is changing, like CDC data. So you can look at the first record. It's deleted. Okay, first data is deleted, so this should not come. And we have the third record that is third record is updated. So you can look at the product ID 3, which is in this category. The price is 436. Now we have updated it to 555.38. Now we are going to implement SCD type 1 on this, and we are going to implement SCD type on the customers table. Okay, so implementing SCD is a big challenge in real time. Even type 2 is a challenge. Type 1 is easy, you can do that. But in type 1 also, if you're using a merge and upsert, every time you have to update the entire table. We have seen that in the merge and upsert session. So here we will keep it simple. We are going to use a SCD type 1 that gets overwrite. We will look at the customers table where we'll implement SCD type 2 there. So to implement SCDs in Delta Live table, it's so easy. So that's the reason why many enterprises have now started using a Delta Live table, because of this reason. Let me just go to the documentation. Here you have a doc called CDC data. You can see a load and transform data. Let me just click on CDC data, and we have this API called apply changes API. And trust me, your life becomes so easy if you're implementing SCDs. You can even go up to millions of files also with this, and you can implement it by a simple API called apply changes API. A quick example is shown here. What is SCD type 1? It's an override. So you need, if you want, you can check it. So we have both Python script as well as SQL script. I'm going to just pull out the SQL script from here. I'll copy it, come back to my notebook. Okay, I'll use the link of this apply changes API. I'll just go here and then I'll paste it just below the product. You can paste it anywhere. Okay, now I'm going to refine this our use case. Let me start creating or refreshing a streaming table. I'm going to create a table called product silver. This is going to be my target table, and I'm going to copy this. I'm going to start using it into apply changes into the live dot. So you know that there would be a relation now. There will be a dependency. I'll use this as a live table. Live name dot product silver table. I've pulled it from here. From So, okay, the product silver table should be created from the products bronze table. Let me take this product bronze and put it here. Oh, sorry, put it here. But whenever you are doing a dependency in Delta Live table, we mention a live keyword. We mention a live keyword. That's it. And now it works like a merge into only. See, what does merge into want? You want to know the like a column on which you are actually matching. So we need to apply the changes based on the key column, and this time the key would be your product ID key. Can you see that product ID? Let me copy this product ID and you can. And now I'm going to say apply as delete when the operation is delete. So that's the reason why at the start of the session I explained you this operation column is mandatory. Without this we cannot do anything. So operation is delete, and in the code they have also mentioned for the truncate, but we do not have any truncate. I'll just remove it. And now you can see update. So when it is when you are applying it and try to understand the source, you might get a multiple updates for that products. So the product price keep on changing. So we need to first sequence it by a timestamp, or we can sequence it by a column called sequence number. So I have mentioned the sequence number here. Again, it's from the source, but you can arrange it by a ingestion date, or maybe at what time this product or this record was inserted. You can do that. But I have a sequence number. I'll just go here and I'll sequence it by a sequence number. I'll pull it from here. I'll come here and paste it here. Cool. Now I'm going to use columns, all columns, except these three columns, because when it's a silver table, my silver table should not contain all this auditing column. I don't need an operation column. I don't need this sequence number column, and I also don't need a rescue data column. So what is rescue data column? Rescue data column is when you are using an autoloader, you get that column every time. So I don't need a rescue data column. Take one more thing. So operation number, rescue data, and yes, I don't want an ingestion date also. Ingestion date, I need it only in the bronze and not in the silver. So let me put it here. Let me put this in a cell. First you have a operation column, then sequence number. It doesn't matter, but let me just keep it. Okay, cool. Now that's it. We just make it like stored as SCD type 1. We are just mentioning as type 1. If you don't mention this, still it's going to be type 1. By default it's type 1. Now I'll just copy this entire to paste it here just below the customers one, so that we are going to implement SCD type 2 on the customers. So before we implement, let me just show you how your customers table looks like. Customers, let's try to run. And when it's a SCD type 2 implementation, try to understand, when it's a type 2 implementation, we get 3 new columns. One will be a start date, one will be a end date, and there will be a flag also, like whether this is active or not. So we are going to do the same thing by using an apply changes API. Look at the data set here. These 5 are inserted. Can you see that? And then the second is updated. Okay, so this customer is city got updated. Can you see that? And the third one was delete. So this customer just maybe he unsubscribed, or maybe you don't want to continue the shopping, he just deleted, and the new record come up, and that's a Robert's record. Okay, can you see that? Now you have a sequence number again, you have an operation column again, so you don't need to do much changes. Just we need to go and change the column name, table name. So this time it will be a customer silver, and this quick copy pasting here. This time I'm going to depend the customer silver based on the customers bronze. So it will be live.customers. It should be customers, correct? And the matching column should be your customer ID. Let's copy this, come back here, and then apply as delete when the operation is delete. Yes, sequence by the column is sequence number. I'll copy it from here, paste it here, and I'm going to put all the columns, removing these all. I don't want operation column, sequence number column, rescue data column, and date ingestion date. I don't need these all column in my silver table. Yeah, that's it. So you need to do a small change here. Just make this as type 2. So people, those who have spent a lot of hours implementing SCD type 2 traditionally, now by looking at this simple apply changes API, you would see that the SCD type 2 implementation would be seamless. It's so easy. Let me show you now. I'll just show you. This is the sales silver, customer silver, product, and the product silver are maintaining the same Medallion architecture. And as we progress further, we are improving the data quality. Okay, let me just click on start. What happened? Wow, you can see here you got your tables now. It looks awesome, and your tables are created. This time we have written only 2 scripts, and you can see only these 2 got updated. Rest all I haven't touched because it's an autoloader again. Let me go back and let me try to check the details now. I'll keep my customers table here. Let us first look at the product table. Let me take a products table and let me take a product silver. Do quick refresh. Yes, let me do a select star from this product silver. Try to run this and let us see when it is in SCD type 1. It's an insert. It's an overwrite. Okay, it's an overwrite. So let me check. Oh, there are 4 records. Let us see how we got 4 records. See, first record, it is delete. Can you see that? Oh, is it correct? Products. Cool. Sorry, it was a different thing, but now it got updated. First one was product. It is delete. So in SCD type 1, you should never get that record. And see, there is no product 1. Second product is updated. Can you see that? No, second is not updated. It is as it is. Third is updated. Product ID third is updated, and you should get a new value. And here you can see the new value 555.38. Can you see that? Cool, amazing. Then 4 or 5 are as it is, and you can see 4 and 5. This is how we implemented SCD type 1 on the silver table, product silver table. Okay, now let us try to compare with the SCD type 2 on the customers table. Let me do a quick select star from the customers table. It's a bronze. Let me do the same thing for the silver. Let customer silver. Let me try to run this. Cool. And okay, this is an SCD type 2 implementation. Let me show you what is happening here. Oh, cool. You can see there is a new column called as a start and the end. And remember, it's a flag. I mean, the flag is inside the end as only. So wherever you have a null, that are active records. Wherever you have a null in the and at, you get that record as active. Let me check. See, record 2, I mean customer ID 2, the new data is New York, but the data has to be maintained. The history has to be maintained. And if you come here in the silver, if you do a quick sorting, you can see there are 2 records. One is inactive and one is active. Can you see that? Wherever you find these 2, it indicates that it is inactive, and wherever you have null, that is active. Then you have a third record that is deleted. The customer is gone. That is deleted. Means it is deleted, but still you should keep a record. That is how the SCD type 2 works. And here you have a record, but it's not active. So to know which are active, which are not active, we just write a simple query here and we'll say where, just take and at is null. Okay, is null. Just keep it and try to run this. And cool. This will show you only the records which are active, but still there are the historical data in this customer silver. So this is how amazingly we can implement SCD type 1 and type 2 using apply changes API in the Delta Live tables. Okay, so what I have done, I have a streaming silver table, customer silver table, but it has all the SCD implementation on top of it. There are some active and inactive records both. So what I planned is, like, I'll be creating an other table which are just having active records in it. So I just written a command here, a syntax that says selecting all these columns. And again, I don't want the other columns like start at and end at. I don't need these two columns. So I've just ignored them. And I'm writing it from live dot. You remember it's a delta live table. We need to use this schema live dot customer silver, because this is going to create a new table from the customer silver where end at is null. I'm going to create streaming table customer silver, and the table name is customer silver active. But this failed. You can see this failed because it has to be enclosed with a function called stream, because this is a streaming table. I'll just enclose this to a function called stream. That's it. I'm going to run this again, and oh, I validate. Validation already validated, right? Okay, you can do, once you validate it, you can see amazing thing again. It can see, oh, customers, this is the raw table, this is the silver table. On top of that, we have a customer silver active records, and we have a product silver, sales silver. Yeah, cool, this looks fine. Let me click on start, and now it gets implemented. Okay, you can do that validation also, a quick check whether everything, syntax and everything right or not. Cool. You should get 6 plus 1 7 tables here. Now we are going to move forward, joining the customer silver active records with the sales silver, or maybe the product silver, and we create a gold tables. So depending on the use case, we can create as many tables as you want. I mean, a gold tables, I'm talking about gold tables. And remember, when it's a gold table, I recommended you to use a materialized views. We are not saving it in a physical tables, but it will be a materialized view. Now let us see how to create a materialized view on top of it. Okay, let me do some analysis based on the data sets here. So the first question I would like to bring is, what are the total sales and the total discounts amount from the each customer? So I have just written the syntax, it's already present. So I'll just comment this line and paste the code here. So this time I'll just put a table name. This is a sales silver table, and this will be my customers. Let me check, customer silver active records or active data, customer silver, and then I'll say this as an active. Rest all the columns are same. We can see total amount, total discount amount. I'm just mapping it with the matching conditions with the customer ID and so on. But yes, I am doing this in a normal notebook, but we need to implement it with the delta live table. We are going to do it in couple of minutes. In couple of minutes we're going to do it. First we're going to test it here. Let me try to test it, but in real time we do that testing in the delta live table only. But just I want to do a quick check here. Let's try to run this, and this should work now. Oh, sale silver cannot be found. Okay, I and the schema name and the table name for this. So what I'll do now, write a command called use catalog. Catalog is not necessary, by default it will choose that. I'll take the ecom project as a schema name. I'll run this. Now if I run this, it should work. This should definitely work. Yeah, this should work now. Cool, it worked, and beautiful, you got this. Let me do one thing. Let me quickly round this at the decimal. Round this, a round of this and this, and we know that which customer. I don't think so. We need a customer email. Instead of customer email, let us take a customer ID, so get a clear understanding on which ID has spent how much amount and how much total discount he got it. Okay, it by customer ID, then customer name. Okay, This should look good now. Let's try to run. I'm going to take the same syntax. Yeah, it works now. It looks cool. I'm going to take it same and I'll put it in the DLT. Now I can put it here, but this time I'll be very careful. I need to use this command called live dot. This is my sales table, and I'm going to use it like a live dot customers silver active. Rest everything remains same. Here we are going to create a table, but this time it's not a streaming table, my dear. This time it's a live table, so you just need to mention it as a live table. And when it's a live table, it's already a materialized view. We are creating a materialized view, and let me give a table name. So it's a total sales and the total discounts amount for each customer. So you can give any view name like total sales and discounts for each customer. Okay, customer wise. Now you don't need to mention any schema name and so on. I'll just put an as here. Let me check. This is all the syntax. We are joining it from live dot, and this time we're not enclosing it with the stream function because it's just a materialized view. Can you see that? It's just a materialized views, and we really don't need all that. So now when I try to run this silver table, customers active silver table will be joined with the sales table, and you can see the graph. Okay, let me try to start this. Not validated. Let me directly click on start and see how it work. No error, I guess. Error. Oh wow, can you see that? Amazing. Oh cool, you can see customer silver active records. We got it with the sales silver, and then we have created a new materialized views. Can you see that? It's a materialized view. Okay, amazing. Now we're going to test that. We're going to check whether that view that we created is correct or not. And you can see the view and the symbol looks something like this. We quickly, can I query this in a normal way? Yes, my dear, you can query it. It's in your catalog. You can just take it and you can query it. You can build a report, dashboard, whatever you want. Oh cool, I think this should exactly match. Yes. Now can I create a visual on top of it? Yes, you can go build a visual. You can take a customer ID. You can see how much they have spent it on the total sales y-axis. Just add a column, total sales, discounts. Wow, this should look amazing. And change the colors. Okay, I'll create a dashboard later on. Let me make data labels, and wow, you can see this. So from completely raw CSVs, we are able to implement SCD type 1, type 2, clean the data, and then create a final dashboard. Obviously we are going to create a dashboard. This is just a visual. Okay, so I'm getting products and the sales. I just want to know which product category has the highest sales revenue. So I have a simple script. I have already written it. So it's a product category. We are grouping it by product category, and then we are ordering it by total sales. So I want to know which category, and based on the category, what is the total sales. Simple. I'll just change the table names. I have tested it in normal one. So it's a live dot sales. It should be sales silver. Let me take this, copy paste it here, and I'll call this as join live dot product silver. It should be product silver. You can see here. I'll copy it from here, product silver, and then the column should be same product ID, and they are grouping it by product category. But I want to save this to a table. Let me take the same syntax. It should be create a live table, and the table name should be total sales by category. Okay, as category. So first we did by customers. Now it's based on the category. And let's check whether everything is fine. Yes, let me start this, and you can see it is running now. Your pipeline is running the scene. Yeah, cool. It is initialized. Once initialized, syntax and everything is fine, we'll set up a tables, and wow, can you see that? So we have just joined the silver sales table with the product silver, the details here. We haven't done any round function for that, I guess, but you get a result, a decimal value, not an issue. Can you see that? So end to end, if you are dealing with 20-30 tables also in the delta live table, it becomes so easy because you don't need to worry about dependencies. Just use a live keyword as a namespace and you can proceed further. Amazing. You can see you got only 2 records. There should be only 2 product categories. Let us try to validate that. Product category, yeah, there are only 2 product categories. One is electronics and the home goods. Let us try to test that. You can just take it, select star from the total sales with category, take this, try to run it. You get only 2 records with 2 columns. Cool, product category and the total sales. Now if you think like, oh, the total sales has to be rounded off, I did not do it, can I do it here? Yes, you can just go back and yes, you can implement a rounding function here. It should work without any, but remember, when you try to run this, it won't get impacted because it's an autoloader. Autoloader says that I have already read that data. So to make this work happen, you have to run this pipeline again from the scratch. I mean, you need to do a run all. I mean, you need to start your pipeline from the scratch. So obviously, we will be doing it once everything is set up. We will run the pipeline from the scratch. Everything will be setting up the tables from the start. Resetting means truncating all the records and starting it from the scratch. We are going to do it in a couple of minutes. So now I'll just go to the workflow. So we have done all the development here. So we have 9 command lines. All it's like there are only one. There are 9 tables in it. Each command line took one table. You can just put all that in one cell also, but it becomes easy for us to track the errors and so on. And if I go back, and you can see in the DLT, we have that ecom DLT. Let me just get inside this, and all the recent updates you can check it from here. If you get inside this, and here you get a option to choose all the all the updates, when it got failed and what was the recent updates, when it was executed timestamp, and every time when you have run it, ID is created for that. Okay, you can check it here. You can do all that logging here. In the logs we have all the details, so I'm not going in detail in the log section, but if you click on any of this log, it will show you a JSON format on, like you can see, as I told you, there is a separate ID getting created. It will show you the data plane, it will show you which cloud, which region, everything, all are mentioned here. And even we can do this all programmatically. So people, those who have implementing the delta live table, they need to know all these events, all the outputs in the form of programmatically. We can do programmatically also. We have done this for one of the client. Here you can see all your tables as a graph. You can check here, and we have a graph view, and we also have a list view. You can check the list, show you all the tables, and on which tables the expectation was set. You can find out from here, and even you can check whether the pipeline, the tables which are status as completed or not, and what are the types here, which are the streaming tables, which are the materialized views, and so on. You can check it from here, and you can also do a quick refresh. You get all the logs as I've mentioned. Now let us try to do a quick start, I mean a full refresh that will start all from the scratch to the bronze, and then it tries to create a materialized view also. And as I've recommended you, if you have dealing with a large amount of data and you have already done the processing, do not use this full refresh. It's not a good practice. Just for the training purpose, I'm showing you. Now it will set up all the tables, and then you can see the graph. So we have implemented an end-to-end delta live table here, ETL delta live table, maintaining the Medallion architecture, improving the data quality, implementing SCD Type 1 and SCD Type 2. Yeah, my tables are setting up. You can see all the details, like how many records got dropped, how many records got written. You can see everything here. You can see everything here. And finally, you got a streaming table. You got a streaming tables, and you got a materialized view. Now let me highlight one con in this, or one disadvantage. So whatever I talked all was an advantages when it comes to delta live table, monitoring, implementing SCD type 1, type 2, streaming and materialized views, and improving the data quality by just using a constraints and using a simple SQL query. We have done this complete ETL. Everything is on the plus or an advantages or the pros, but there's one con and one disadvantage. Maybe no one will tell you this. If you go to the catalog, you can see, if you go to the catalog, like all our bronze tables, all our silver tables, and all our gold tables, all are attached to one single schema. Everything is in one schema. So why is this so? Because when we created a pipeline, we mentioned the schema name as once. So that only one schema name, it will attach all your tables to that schema. So is it a good practice? So it all depends on the use case. So few people always implement Medallion architecture. They say a bronze schema, silver schema, gold schema, and they'll try to push it. Now with this Delta Live table, can we achieve this? It is a bit difficult because you have to create 3 different pipelines again, bronze pipeline, silver pipeline. But again, it becomes difficult managing all these 3 pipelines. But what I can suggest is, if you generally want to use an DLT for the entire project, you push all that to one schema. But the enterprises say that we always maintain 3 different schemas. Then you can do mix and match. Like you can use a Delta Live table for data ingestion and silver maybe, and then you can create a gold tables by using your notebooks, as I have done it, and you can automate all that DLT and the normal notebook by using the workflows. You can do that by mixing and matching your workflows and your Delta Live table. Okay, that's all about the DLT, guys. You can see I have implemented from the scratch. So this was on the highest demand. So many people reach out to me saying to implement a DLT. So I have done it for you. So I request you to please subscribe to my channel, like this video, and share it to your friends and colleagues, those who are looking for data engineering ETL using a DLT, using a Databricks DLT. Okay, so this will clear most of the concepts. So whatever we needed, I have implemented everything. Medallion architecture, implementing SCD type 1, type 2, handling a CDC data. We have created a streaming table, materialized views, and so on. Thank you very much for giving this opportunity. So I hope you like this video. If you want me to create projects in the same way, please do comment it. So I'll definitely make a project on this. Thank you. Have a great day. Bye bye.